morning to all. I am Dr. Krishna Rao, working as professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I am going to discuss about the course description of the course Signals and Systems. So its code is AECB14 in Institute of Aeronautical Engineering. And I am going to discuss today about the total course description, especially more focused on the Bloom's Taxonomy and program outcomes, program specific outcomes and course outcomes. Okay, how we write it, and it is basically a very people generally face problem, especially faculty, younger faculty, and not only younger faculty, several faculty they face problem in writing. So I thought this will give some guidelines, some understanding of how to write this, and general structure, how the structure should be there, and all those things I will be discussing today. And the course here is Signals and Systems. The outline of my lecture is, first I just say a few words about the outcome based education, and I review the POs of the institution and some kind of sample POs and program specific outcomes which are specific to our department and more generally applicable to the similar departments, and course overview, course objectives, course outcomes, and finally the summary of the course syllabus. So this content basically meant for giving an overview of the total course which I am going to teach this semester to the students. Basically this is for the students, and your first class, whenever you start the class of any course, it must contain these kind of details so that student is inspired to see what is going to happen in this course, what the student is going to learn from this content. This should be very clearly told to the student. Otherwise, you cannot basically inspire the student, and it is a mandatory thing, I feel. Outcome based education. This now it is very famous in India also. And here basically emphasis moves from the content, what is taught, to the outcome, what a student will be able to do or to know or to think. So this is what is the emphasis movement. In the sense, in the traditional education system, what we used to say, whatever the teacher prepares and the faculty prepares for that class or for that course, he or she will go and without taking any feedback from the students, without discussing about any of the difficulties of the students, you just go and teach whatever you have prepared. And there was no system which gives you some kind of feedback to the teacher, saying that what topics are not understood properly, what kind of content it is, what kind of difficulties the students are facing. All those things were not attended. It is not that all faculty will do like that, but most of the faculty, because there were no guidelines for the faculty in that direction. So that's why this outcome based education, basically outcome from what? Outcome from the student, not from the faculty point of view. Faculty may be an excellent faculty and a senior professor who has excellent bird view of the total subject and excellent instructor. All those things are okay. But even then, because in the class, what happens is there are different kinds of learners are there. Some people, they like to see everything on the board. Some people, they want to listen to the voice of the teacher and understand the speech. So because they are interested like that. Some people, they have more motor skills and they want to do practically in the laboratory, or they want to experience and do. They may not like seeing on the board, or they may not like seeing, listening to your lecture. So that is the kind of, there are several variations. So basically what we have to do is, some kind of normalization we have to do. That is you have to normalize the interest. That means everybody, irrespective of their type of learning, every student should be able to pay attention to your class So that kind of normalization or some kind of inspiration for them you should give. Otherwise, everybody wants in a different way, which the faculty is not aware. So naturally, it goes one-sided teaching, and ultimately the outcome we did not have earlier the system where you can really assess what is happening among the students. Okay, so that's why the outcome-based education more focuses on the student-centric learning. It is nothing but student-centric learning, student-centric teaching. You can say that student-centric teaching also. Okay, so I mean your teaching is always aimed at what the student is going to understand, what the student is going to know from you, what the student is going to think about the content which you are delivering to you. So that is more important. What the faculty thinks is not important. So, but anyway, you have to think in a right direction and more efficiently as a teacher. But over and above that one, you should take care that your content is delivered properly, it is received by the student properly. Otherwise, your 64 hours to 72 hours of one semester course delivery will become not that much fruitful. Okay, so this kind of learning is also called as active learning, and we all know it. And I directly go to the outcomes. The first outcomes we talk about is program outcomes. The program means here, if it is a engineering college, like us, it is the BTech course or BE course. Program specific outcomes means, and they are the specific to your department, and your department is distinct in, your department is distinct in delivering certain content, and in some kind of laboratories, some kind of practical activities. I mean, it could be the product development or it could be the research oriented. Okay, lab. So that is what is program specific. So this we are going to highlight what our department has. For example, similarly, the course has the course outcomes. So these are the things which I am going to discuss in detail in this lecture. So when we talk about Bloom's taxonomy, I'm not going history part of that one. So it is basically a multi-tiered model of classifying the cognitive processes in the human brain based on the level of complexity. So what it means is we exhibit different kind of thinking process. In fact, we intend to do something. Then first thing is you are going to think in your brain. Then you have to say to somebody, and afterwards, if you have to put that on paper as a plan, you have to put on the paper. Then you have to execute it. So that the main basic tier for this is the thinking process, what is going in the brain for all activities. So in your brain, and based on the cognitive level, that is complexity. Okay, because brain is basically a cognitive device. So it has different capabilities. Different people have different capabilities. So it is called the Bloom's taxonomy. It is a model, basically multi-tiered model of classifying these cognitive processes which are happening in the human brain in different kinds of situations. Okay, so that is based on the level of complexity. So different levels have different complexities. That means the decision making process in our brain, and it goes into different levels. That is low level thinking. Okay, low level perception first. Whatever you are hearing, let us say you are hearing or you are seeing it, and you are seeing the real world objects, or you are listening to somebody's speech. So first thing is perception. Your sensor, your ear or your eyes, they are the sensors. They are acquiring the data, and they are converted into electrical or electrochemical ions, and they are transmitted to the brain, and the brain processes at initial stage low level complexity. I mean, it's not really complexity. It is an order basically. Okay, so at low level it will do. Then next level, like that. There are several levels of cognitive process which goes in the human brain. So that is what basically we should understand. If we understand that one, basically how the student is thinking, how the student is about to learn the content, and how he or she processes your information, it will be very clear. Okay, so here the Bloom's taxonomy is a good tool, and it provides a common language among the educators, like swaras in music, and it is some kind of language, and the teachers, all teachers must know the terminology, the definition, and the motivation behind the Bloom's taxonomy. So that several people on common dais, they can share their problems and they can solve their problems in the field. Then the Bloom's taxonomy helps determine the alignment of objectives, learning actives, and assessment in teaching learning process. Okay, we all know we are going to prepare the regulations and syllabi for different courses. This Bloom's taxonomy helps us very much, as we have seen practically. And Bloom's taxonomy stretches the educational possibilities to give greater breadth and depth to the courses and curricula. So, because as the systems are becoming complex, the level of knowledge which you are supposed to acquire is becoming complex day by day. So, what happens is we have to, review our syllabus. We have to review our instructional procedures, assessment policies, methodologies. All those things will undergo from time to time changes. And when you are going from old system to new system, definitely you have to consider the Bloom taxonomy, and it is very, very useful. Now, this is the pyramid, basically triangle I should say, or I can say triangular pyramid. So the lower level is the remembering level. These are the cognitive levels, different levels. It is a low complexity process, remembering, recalling the relevant knowledge from the long term memory. You are just recalling it. There is no input path. It is only output path. Something triggers you. Somebody asks you some question. Then immediately you have to recollect from the brain, retrieve from the memory and answer it. That's all. So it is a low level complexity. Then understanding, making sense of what you have learned. And you told something and the other person asks why. Why it is happening, explain to me or illustrate me so that I can understand. So it is not just recalling. After recalling, you should make sense of it. Whatever you speak, you should have some sense. So some sense means it should convey the meaning. What it is not just by hearting and telling. You should be able to convey the meaning of that to the other person. That happens if you really understand, and if you store that knowledge at a different level. That is nothing but understanding and comprehension. It is called summarization. That means you have compressed the data. You have the capability of bird view. You have the capability to retrieve the thing, and randomly, if somebody asks on that content, you will be able to answer immediately. So that is possible only if you understand the thing. That means you have to extract the sense out of the content which is there in your brain. Okay, that is what is second level. Third level is apply. Then you understood, immediately to recall from which content you have to recall, it. Then what you do? You have to apply that, because we are all engineers. We have to apply that knowledge to gain new ways. That means you apply it, get the results, do something, interpret the results, then invent something new, or contradict. If any results are contradicting with the existing statements or theories, you have to revive that again. Okay, so that's why you always apply the knowledge. For example, if you don't apply the knowledge, there is no way the learning process stops there. Then your pyramid stops there. So a real learner, in general, everybody is a learner actually. So not only engineers, not only teachers, everybody in this world is a learner, and a farmer in the field, or some driver in the bus, some auto person, everybody, every day we will be learning. And that's why we will be automatically applying even without our knowledge. Whenever we have to make some decisions, we will be applying our sense there. There is understanding. Okay, that content we will be applying, and then we will be taking decision. Okay, so application is basically applying the knowledge in the field, gaining new insights into the problem, and either you satisfy with that, or you say that something new way is there. Okay, so application is the very important thing. So after you apply, then what you have to do? You have to analyze the thing, breaking the concept into parts and understand how each part is related to one another. That means you are given a system. First you want to make a system. If you want to make a system, what you will do? What is there in that? You have to really study first. See, in nature, there are so many objects available. We mimic the nature by creating new products or new inventions. So if you take fluorescent light, it is something like a moonlight. and we have replicated it. And okay, so it is an invention made by human beings, whereas the concepts, I mean, many of the concepts are derived from the nature, and we simulate the natural principles, and again we create our product as a part of technology. Okay, so that's why analysis is built into our learning process and our thinking process. So you have to analyze. If some bigger problem, if you see, and you convert that bigger problem into small parts. If you see bigger product, reverse engineering, divide it and study what is there inside. Once you understand, analyze what is there, that means you are some natural object, some natural process you are studying. You have to make so many experiments, and you should analyze the reasons for that results, whatever you are seeing in the nature, and then frame, I mean, that the results, you have to interpret those results. That is also stored in your brain as knowledge. All this is called knowledge only. Okay. Then after analyze, what you will do, you have to evaluate. There are several situations, making judgments based on set of guidelines or some constraints or requirements, whatever are called. So what happens is, you have to evaluate the thing, because see, for example, I am searching for some cab, for example. Okay, the cab person told that it will take half an hour. Then what happens? If the cab person says half an hour, then I have no time to go to office. So immediately I will search for alternative. So I have evaluated here. I took the data, I understood the data, and I evaluated and applied that, and analyzed, and finally I evaluated and felt that I cannot go to the college or institution or office in time. So then what I have taken immediately, I have based on this judgment, based on this decision making, I have gone for alternative way. So at every point of time, every day, whether to eat or not, whether to drink or not, at every point of our life, we always go in every small or big, in all processes, all these levels are involved. Each and in 1 minute, if we take some decision, even in that 1 minute, all these levels are involved, and all these cognitive processes are happening in our brain, so that we ultimately reach the optimum decision to move forward. Okay, on that issue. Okay, so that is what is evaluation. So then, I mean, I know how to recall. If I don't know, I will open the textbook. It is also called recalling from textbook, I can say, and understand the thing which you already have, apply the thing, analyze the thing, evaluate the thing. These are all different cognitive levels. At all these levels, you have acquired abstract knowledge. It is not the simple data. Remembering is only, you can say, it is something equivalent to some data. But second level onwards, they are all complex process. It is, you can say that it is the abstract knowledge. Abstract knowledge means logical. You have to think logical, and how that is stored, at least I am not clear at this point of time. I am curious to know, probably. Okay, so it is called abstract knowledge. How you different data things are retrieved, and how they interact, how finally when you reach. So what is the physical process going on, biological process going on in the brain? That is also has been studied, and it is halfway through or more than halfway through. But these are things as a human beings we perceive. Okay, then after getting all these levels, now I am in a position to create something. That means I have analyzed something. Now if somebody wants me to synthesize this, that means you separated the parts, add the parts, and create the product again. And you need not create the same product. You will be creating something else, because you are taking some different parts which you have not seen earlier also. Okay, so you are trying to everything here. When you want to create something, definitely you have to go all these levels. You cannot say that I have not thought, I have not recollected anything. It is there in my blood, or nothing. I'm superpower, or I just apply. I can create something from the vacuum. Okay, many people say, and they are all. At least I don't believe in all those things. So if you are creating something here, a product or something, it should come from you, or it may be single person, or it may be group of people, it may be a big team, whatever it may be. But it is the collective effort which is going through all these levels, and without that you cannot create. So if you want to create something, you require all the skills, other lower level, cognitive skills. Okay, same thing is applicable for the teacher and students both. Here, knowledge. I think I have already explained this. Different words are there. I don't think, you can go through afterwards all these things. And program outcome. Let us come to the program outcomes. What is program? Program is nothing but BTech. Okay, we used to say earlier in our days when we were studying, we used to say the BTech course, MTech course, like that we used to say. But the terminology now as per the outcome-based education, it is the BTech program, I should say. It is a BTech program or MTech program, undergraduation program, post-graduation program. So that is what is BTech or MTech. Maybe MBA or MSc, any kind of degrees, you should say. Okay, and these program outcomes, what ultimately, say a BTech student, for example, what is that you are expecting the BTech student to learn? What is that you are offering to the student to achieve? So that is what is program outcomes. Actually, these are the outcomes which are achieved by the student, not by the teacher, not by the institution, not by the department. Okay, it is your responsibility. You are facilitating the department, faculty, all institution put together. We are facilitating the student to achieve different kinds of skills or different kinds of abilities in this program. Okay, they are called the program outcomes. So here I have marked in a red line, that is knowledge. Okay, it is knowledge in the brain. And you are aware of something else, that is knowledge. And skills, you have certain skills. It may be thinking skills, or it may be motor skills, or it may be something else, some other skills which are related to some other senses. And attitude, what is your attitude? Basically your attitude and your behavior, they are dependent on your personality basically. Okay, and I strongly believe that personality is again linked, maybe more than 80% is linked to the genes. And I think not by simple training by somebody when you are young. Okay, because we grow up children in different, in the same environment, different children, but they finally pick up, because whatever you are giving guidelines are same to all children in the house, but some one child will pick up in a different way, other child will understand in a different way. So why the difference is coming? Definitely I feel it is because of some kind of biological structures, maybe in the brain. Yes, mostly in the brain, and which are determined again by the genetic content basically. Okay, and but here it is not that we are going to modify their skills. Basically, we have to make the student discover their own capabilities. We are not inventing anything out of that. It is there already within the student, and maybe in these 4 years, if you help the student where that person is strong, in which skills is strong. So in that way, if you can educate them, he or she, they can take at entry level itself, they can take right roles in their career. So okay, that is what is important here. Then these are the outcomes. There are 12 outcomes. I'll just rush through. First one is engineering knowledge. Engineering knowledge is based on mathematics and science, and of course engineering principles. Then second one is you should be able to, the capability, and the student should be able to identify on their own, formulate some problems. They have seen something happening. Okay, then you have to solve that problem. Somebody is facing some problem. You identified it, then formulate the problem. Then review the literature. That means already whether something has happened or not. You can review the literature and understand something, because you are not the first person doing it. There are millions of people are there in the human history. They have done a lot of study. Their forefathers have done for thousands of years a lot of things. So you have to analyze considering all those inventions or all those discoveries basically. And now you have to apply that knowledge, and you have to analyze your current problem and apply them. Again, first principles of mathematics, natural sciences, and engineering sciences. Okay, so PO1 and PO2, they are mostly related to mathematics and sciences, I should say. Then PO3, here you are designing and developing a solution. So this is where the technology comes. You are creating something product or creating some concept. You can create some concept also. You're using some analytical tools. You can derive some equation. You can find some new relation amongst among the data, or you can extend the concept of some mathematical equation. Okay, its utility, all those things come under this. And developing the product also comes into this. So you can develop a new concept, you can develop a new product, you can develop a new idea. I mean, any kind of things, but all without affecting our social structure. I mean, society. Okay, we should consider that your invention should not harm the society by and large. Okay, and that is there anyway as a separate PO. Now, so PO3. Okay, PO4 is conduct investigations of complex problems. Here you are not creating anything. Your intention is not creating some new thing. Here intention is you do investigation, that's all. Investigate and you inquire into the thing, some problem, and identify the reasons for that and report to somebody. Somebody wanted you to do this investigation. So do the investigation, get the results, analyze them, interpret them, and summarize them, present to the people who by whom you were asked. Okay, so that is what is you are just investigating into that. Then modern tools uses. Nowadays you have starting from civil engineering discipline to computer science or machine learning, the latest technologies, and electronics, triple all branches, actually all disciplines, basically they use computer tools now, automated tools. Okay, and the student must have the knowledge of all these things. So you the students, you should know all these things. Actually, all these things must be known by the students. That is the reason I am telling in the class also. So these first 5 POs relate to your main students. So to your technical skills, basically the 5 POs. Then another set I prepared. I have separated them into another 3 set, 6, 7, 8 POs, 6, 7, 8. And this is 6 is engineering in society. You have to consider societal requirements also whenever you do any activity, any engineering activity or invention must be in synchronization with the interests of the society, that you should see. Otherwise, your engineering knowledge is waste. And after all, you are living, engineer, you are paid from the earnings of the total society. That is your earning, basically, even if you think in that way. So you have a responsibility on you to consider the society before you do any engineering activity. Then PO7 is environment and sustainability. Is a very important thing. We have to protect our environment, and you should, when you invent some electronics device, the radiation level should not be very high. And if you say some biomedical product, you should not give shock to the patient, or suddenly unexpected things should not happen. Of course, they are all very well documented as a form of standards. Different standards are there. And your thing is you maintain the standards and to maintain the quality of the environment and sustainable development without affecting the nature. That is what is there. Then 8th one is ethics. So this is very, very important thing, which because environment, environment is our control. If we want to do something, we can do. Okay, they don't talk, but ethically, it is something related with your human relations. And if your team has ethics, you should have engineering ethics. I should say engineering ethics. So these ethics are different from what religions say, because the religions, whatever they say from time to time, they will change. But human values and ethics, I think they won't change that much fast. Okay, and different religious spiritual leaders, different religions, they talk about different moral values, and ethics are different. Moral values are different. Moral values are most probably they are for the convenience purpose. At certain point of time in the human history, they were framed, and they may not. 1,000 years back, when you say something moral, today it may not be a moral. Okay, so like that, the morals are very volatile concepts. The morals. So I am not talking in that way, because we are scientists and engineers. When we talk, we don't talk in the air. We always have scientific, proof for that. And our ethics are engineering ethics. So basically, what kind of ethics this is? For example, you cannot say you have. For example, you students are there. You are not supposed to copy from somebody. It is an ethic. professional ethics. You are a professionally, you are a student now, correct? So why the exams are conducted? It is to test your knowledge. Okay, you should prepare well and write the examination, or if you are not prepared, fail the examination. Nothing wrong in that. Okay, fail the exam, or maybe you have one backlog, sit there and again write. In that way, you can build your ethical background, and that is what matters basically. Okay, I probably have no time to tell. So I have plenty of things. I have never deviated from professional ethics at any point of time in my 36 years of service, and really it is not something which is not impossible. It is definitely possible, but only thing is we don't take it seriously. So you should take it seriously, professional ethics. Okay, and your plagiarism, paper publishing, doing research, copying something, everything comes under the ethics. Okay, because separate session is required for that. I will stop it here. Then, so what about P6, P7, P8? These are all related to individual as an engineer and society or environment, outside world basically. Okay, first one is society, people, and other one is environment, physical world, and the other one is ethics in your team, in your again society. Okay, society means small team of engineers in your professional domain. Okay, so all three. That's why first 5 technical, next 3 they are individuals' relation with the outside world. Like that, I feel. Okay, then next things, there are 4 I have given. PO9 is individual and teamwork. This is how you execution part of it. When you execute within a team to do some work which is given to you in multidisciplinary settings, because if you are a computer science engineer, when you are developing a system software, probably it is not just system software. You will be interacting with so many people. For example, electronics engineers who have developed the device drivers for the hardware. You have to consider them. You may be knowing very good things about the operating system and real-time operating system, but they are all linked with the hardware. They are all linked with the device drivers. So you should be able to interact with other people. So many multidisciplinary. Even if you take a single product, definitely you require to interact with the engineers from different disciplines. It is a mandatory thing. You cannot develop a product without their interaction. So you should know not only interacting with your own discipline people, other discipline people also. Okay, that is technical part. Okay, even otherwise also, as a human being also, you have interpersonal skills. Different interpersonal skills are there. Somebody will become angry very fast, and somebody is very cool, is least worried about the urgency of or he's not worried about the time schedule. All those things are all experiments will be there. You should be able to somehow make the product successful, and that is where your if you are successful within a team as a member, there is every chance that you will become the team head, team lead after some time. Otherwise, your prospectors are not there. Correct? As an individual, if you are not interacting, how can you manage the team? So that is directly related to that. Okay. So you should see that from the beginning, and even you take students in the class, all of you students in the class, and when I give some project work for 5 people are combinedly doing the project, it is a teamwork basically. If you give minor project or major project, or if I give some independent project, or if you want to do some kind of research work, so it is a collaborative activity. You should learn. Otherwise, you won't be successful. Then communication. The communication is different ways. It is one will be written communication in the form of a report, and if you are asked to give a presentation, you are supposed to give the presentation. It may be on the PPT or it may be on the oral. And if you have the conferential viva, and you have to answer the examiner's questions very clearly, very accurately, point to point, you should not talk, because you have only few minutes of time. So how efficiently within short time you can express to the other person, that is also part of communications, not only written documentation, not only PPT presentations. Okay, and all these things will come under the clarity. You must require the clarity. Communication means it is not just go on talking whatever is there. It should make some sense what you talk. Okay, and that is what is communication. And so basically PO9 and PO10, they are related to the team basically. And of course PO11 also you can bring to that extent, because as a project manager you have to manage the team members. and you have to coordinate so many activities. So basically, as a project management person, as a project manager, here also you have the class representative will be there in your class, and there will be, for some project if you are taking with the help of some professor, then maybe somebody will take lead and you will be contacting, coordinating the activities. Among the 5 people, one person will be interesting and he or she may be interested to coordinate the other people. Okay, so like that you come across the teams and you have to manage the small team. It is not just for project management done by MBA people or some CEOs are like that. Even in the class also you come across what is the project means. It is a student project for you. Semester course itself is one project for you. How you get internal marks, how you get external marks, how you prepare for the examination, how you prepare for the Viva, all those things come under the one project. So you should be able to, the student should be able to manage your project properly. And of course, finance also will be there. In your case also finance will be there. So that is what, you should have that kind of skills also. So PO9, PO10, PO9, all 3 I can say that human interaction basically towards a common goal. Human interaction towards a common goal. Applicable for the faculty, institution, an engineer in a company, and a student in the class also. All are applicable. Okay, that's why we study here. And the last one is PO12. It is the lifelong learning. It is true for everybody, and you have to those who are capable, who are interested. I am saying capable. Okay, it is a different session. I have a different opinion on that. So ultimately, your capabilities and incapabilities determine your personality. That is what I believe in. So it is not teacher is saying or not. And you have an internal zeal that is again based on your maybe genetical content. Most of the times it's genetical content. And without genetical content, artificially, external world, external people from outside can never create any interest in you, never inspire you. It is there internally. If it is already there internally, we only trigger, we only point you to go there and like a Hanuma. Okay, so you don't know your strengths. So the teacher can make you know about your strengths. If you do not have strengths are capable within you, it is not possible basically. Okay, but everybody is capable in different sense. Okay, that is also issue. It is not that only if you don't get marks you are not useful or something like that. Okay, so lifelong learning. Those who update their knowledge continuously, who has an urge to learn new things, they will definitely lifelong. Nobody can stop them from learning. Somebody who is not interested, you can never make them to learn lifelong. Okay, for certain period they will learn. That is to get BTech degree over. Okay, after getting BTech degree, not required. So some people will stop there. Some people will go for higher studies. So it is again individual built up. Okay, so but lifelong learning is recommended for all students in this class because you are going to you have to be successful in your career, and technology is changing every day. Okay, even professionally also, and people will change, and people mentalities will change, environments will change. Okay, if you join a multinational company, it will be different, and when you join a local company, it will be different. Hardware company is different, software company different, services company it is different, and marketing company it is different. Okay, and if you become an entrepreneur, your skills are different. So lifelong learning always will be there, whether you accept it or not. Okay, but you have to make it somehow. You should pull it towards the positive results. Okay, so these are the 12 POs. These are common for all engineering branches, engineering disciplines, I should say. And let us come to the program specific outcomes. These program specific outcomes, these are for our department. These are applicable, and every institution has, every department has their own, based on their strengths, the strengths of their faculty, based on the strengths of their laboratories and other facilities within the department. It depends on that. And here I have some sample things. Graduates will have ability. Graduates means after graduation, after getting the degree. So build hardware and software. That means at the end of the course, build hardware and software for embedded systems and for signal processing applications. Signal processing is basically the brain. If you want to build any intelligence, it is basically signal processing. Electronics people call it as signal processing. Computer science person or data scientist, you will call it as a data. Otherwise, everything is same. Okay, because whatever features you are extracting from the physical object, they are nothing but data, for the data science engineer, and same thing for the electronics engineers also. Okay, mostly these are all interdisciplinary. You cannot separate like that, but our department has this focus. And second one is focus on the application specific integrated circuits. We have excellent VLSI laboratories and tools, development tools, and we have virtual instrumentation laboratories, and that is the reason we have these 10s. And our next focus is on the VLSI side. And third one is make use of high frequency structure simulator, that is HFSS, for modeling and evaluating the patch and smart antennas for wide and wireless communication application. This is basically linked to antennas, high frequency part. Okay, generally we say that everything is data, everything is something. But if you talk about 3G, 4G, 5G, they're all communication systems. Basically operate the physical layer of this system is basically RF transmission. You require antennas, you require microwave devices, high frequency devices everywhere for communication. Otherwise, you cannot communicate at all. There is no way you can communicate. So, some people, and very good if you can go towards antenna design and microwave side, RF side, you have plenty of opportunities. But unfortunately, we don't realize, because you students should be educated about all these opportunities, specifically in the domain side. Okay, why should you migrate from one domain to another domain? You have spent 4 years on this. So program specific outcomes, they are meant for that. Okay, so more educate and more develop more skills specific to your department, specific to your discipline. These are our 3 things. And coming to my course, it is the course structure. The signals and systems is the course, and course structure is given in this table, and the code is AECB14, and it is a core course in the 3rd semester, and this is a theory course basically, and 3 credits course it is. So that is how it goes. So let us move to the course overview. So course overview. This course basically is the signals and systems is an introductory course. This is the first course you are studying in the ECE, along with electronic devices and circuits. It is a circuits part of that one, and this is the just complementary part of that one. Okay, the signals and systems, analysis of signals, analysis of systems, electronic systems, electrical systems, electrical signals. There is no electronic signal, correct? Electrical signal. If electrical signal means conduction of electrons. If you add holes, then should not say that electronic signal. Even then it is electrical signal. Electricity in the semiconductor, you should say. Electricity in the conductor, you should say. There is no electronic signal. It is only electrical signals always. Signals and systems is an introductory course to an analog and digital signal processing, because you may say that signal processing is in the final year course. It is not like that, because that is digital signal processing. But already when you use a diode, single diode for half wave rectification, so you are cutting down the positive part of the, see for example, I have a sine wave input and I have passed it to a single diode. What I will get? So here another positive cycle and here another positive cycle, correct? So this is what is I get at the output. This is input, this is output of the diode. So only positive cycles, half cycles are passed. Okay, and during negative half cycles, the signal is 0. The current or voltage is 0. So what I am doing, I am processing the signal here. So signal processing is not something which you are studying in the 6th semester or 7th semester. It is the second semester itself, or the first course itself is signal processing. The electronic device and circuits itself is nothing but signal processing. But the signals are analog signals there. Analog signals, of course, we have analog simulators and analog computers. They are not that much popular like digital computers, but still they are there in some places. And the devices, whatever you are studying, the hardware, they can process the analog signals directly. Okay, so that's why the signals, you should not say that is a digital signal processing we are studying late in the course. No, in the first day itself we are studying the signals. So that is what is half wave rectifier. Amplifier, if you take RC coupled amplifier, the output of amplifier is amplified. So you are modifying the signal characteristics there, amplitude. And if you pass through a low pass filter, you are cutting down higher frequencies. So what it means? You are cutting down high frequencies means you are passing only low frequencies. You have manipulated the signal characteristics there. So all these things also come under signal processing. It can be Butterworth filter. It is a signal processing. So only thing you should say that is analog signal processing. Okay, because you have not digitated the signal, you have not processed the signal using a computer. So a computer means it can be digital signal processed. It is not Pentium computer or it is not something Mac book like that. Okay, computer means any chip which can calculate your 8051 microcontroller is also a computer. Of course, okay, small low level computer. It can do several. You can do using that. Okay, but basic computers are signal processors basically, which have the hardware addition units and hardware multipliers, barrel shifters, different kinds of resources are there on that. Okay, they are called processors, computers, not controllers. Okay, so processors I should say. So that's why the signals and systems is a parallel course. It is an introductory course parallel to electronic devices and circuits, or electronic devices and circuits you must have studied this in the previous semester also sometimes. Okay, so but it is nothing to do with electronic devices. Without studying electronic devices and circuits, EDC, also you can study the signal processing. Analog signal processing means signals and systems. It is an integral part of system, including communications, radar, defense electronics, speech, audio, image processing, and consumer electronics everywhere. Okay, and the course presents the basic concepts of both continuous time and discrete time signals and systems. Continuous time and discrete time. What is continuous at this point of time? I won't be able to fully give details, but I can say, let us say one signal like this. I will sample this one. Discretize in time. So I have samples here. That is what we will do before we store onto the computer before digitization. So discrete time, in time, you are capturing only certain samples, you are leaving certain other samples. So this is the starting point for that, but they are not the digital signals. You say that we have not yet started the digitization process. In this subject, we don't digitize basically. Okay, we just study theoretically up to continuous time systems. We don't talk about digitization. We don't talk about the binary words. We don't talk about the digital data. Okay, this course won't touch those things at all. So then the representations of signals and systems in both time and Fourier domains. The signal can be expressed. What is signal? It is a physical quantity converted into electrical energy. That is the signal. Okay. So if you take speech, for example, you put a microphone, capture my speech. You can plot that speech waveform continuously, dynamically with time on the oscilloscope or any display device, or you can record it on a tape or like that. Okay. So that is what is time domain, and you are representing the electrical signal in time domain. Now, if you want to analyze this, you have to transform this into some other domain, like Fourier domain. So many domains are there basically. I don't want to confuse you with all those additional new terms. So initially you will be studying about the Fourier domain, which is again linked to the frequency analysis. What are the frequencies contained? Frequency means what are the sine waves? Frequency, the square wave has no frequency. You should not say the square wave of certain frequency. You should say sine wave of certain frequency. Of course, square wave is composed of several sine waves. It is sum of sine waves. Okay. So like that, frequency analysis will be done. That means how many sine waves are there in the given signal. That is the kind of analysis. And that analysis is called Fourier analysis because we use Fourier transform for it. So Fourier analysis, normally if we plot as it is, signal or voltage versus time, I call it in time domain representation. Fourier domain means frequency analysis. Then more generalized representations are there. That is also studied in this course. Laplace domain, Z domain. These are the two. Laplace domain is meant for the continuous time signals, which I have shown here. Okay. This is a continuous time signal. This is the discrete signal. Correct? For discrete signal, I have the Z transform. For discrete time signals, I have the Z transform. So Laplace transform, Z transform, they go together. One for continuous time signal, analog signal, other one for the digital signal. That is what we have to, we will be studying in this course. Okay. I think you are all inspired to see what is going to happen in this first introductory course, because it is an introductory course and you must be, is the second parallel course, introductory course along with EDC in this semester. So I think you must be curiously waiting for this course content. Okay, I feel that most of you have understood what I told at this level. Then the course objectives here. So this is something connected to you, and here the students see what I teach is not important. See, I have certain objectives. Okay, that as a teacher, as a professor, I have certain objectives. Those objectives I am claiming here to you. Okay, I am telling to you that with what objects I am going to teach this subject to you. Okay, and then once you know my purpose, then you will have more interest and how you decide how to learn this subject. Okay, and here we have, first I talk about the analogy between the vectors and signals. Vector algebra is a mathematical concept, mathematical framework, and signals is electrical signal. Okay, so far we discussed about some fundamentals about the signals, and orthogonal signal space, vector spaces and signal spaces, and you are approximating the signals, you are approximating the vectors. So there is a remarkable correlation, remarkable analogy between the vectors and signals. So if we understand, because M2, M3 subjects are there for you, you must have studied one of these mathematics course, the vector algebra. It plays very important role here, and that is what my intention. Okay, I just review I don't teach each and everything of vector algebra. Whatever is required for me for my signal analysis, I use that one. Okay, so I introduce you, I review the vector algebra, important aspects of vector algebra, and I introduce you the signals, what is orthogonality of the signals, signal approximations, and signal classification also. How I can classify different signals. So this is also one of the, I got it. So signal classification. Okay, then I will be introducing the systems. After introducing the signals, systems. What is a system? Anything, whatever is, there is a system. Attendance system is there. Okay, appraisal system is there. Examination system is there. Like that. Okay, and for a teacher, is a delivery mechanism, is the delivery system. How I am delivering? Is it the videos or animations or so? Everything is a system. Okay, so here system is a set of operations applied on the signal, because signal I have to manipulate the signal, correct? I have to manipulate the signal, I have to do many things, process the signal in different ways. So to process the signal I require a system. Okay, so the system is nothing but a set of mathematics, what equations you apply for that, and that is what is system here. Okay, and an operation called convolution operation. See, if you ask a 6th class person or up to 10th class, if you say that what is the basic mathematical operation, they say that addition is the basic mathematical operation. Mathematical operation, addition and multiplication. Okay, division is the inverse of multiplication, subtraction is the other side of the instead of accumulation, your deletion process you are doing. Okay, but multiplication is also a repeated summation. So ultimately there is only one accumulation, and removing something is deletion. Okay, so accumulation is the only thing which we talk about. So when we say that the basic mathematical operation, generally school students must say that is an addition. Okay, similarly, if a signal processing person, an electronics person is asked what is the basic operation on the signals, you should not say that addition or subtraction. You should say that convolution. Okay, not even convolution. I am going to show that is not done. Not only convolution and correlation is also there. Convolution and correlation operations, they are also higher level operations. Sum of products. I feel that sum of products is the basic operation. You should not say product or you should not say sum. Sum of everywhere in Fourier transform, in finding correlation, in convolution. Fourier transform, correlation, convolution. These are the total signal processing comprises only 3 topics. That is transformation, convolution means filtering, and correlation, finding the similarity. Okay, these are only these 3 concepts. Total signal processing, total signals and systems is dependent on only these 3 concepts, and the basic operation here is sum of products. Okay, so basically sum of products means A1 B1 plus A2 B2 plus A3 B3, like that. Okay, so that is what we will be studying here, and we have to analyze the signals and linear time invariant systems. Basically, we talk about only linear systems and time invariant systems. The system doesn't change. Like human mind, at 9 o'clock today morning, we say something. At 10 o'clock, we say something else. But the system, the electronic system or electrical system or any machine, it won't say like that. Okay, because whatever guidelines you give, it works as per the its natural principles. So it is a time invariant. Whether 9 o'clock if you conduct the experiment, or night 10 o'clock, or next day morning, or weekend, or week beginning, anytime you do the experiment, you will get the same result. You must get the same result. In the same way, our systems also should behave in the same way. Okay, but there are a few systems, time variant systems. Actually, in nature, most of the things are time variant. I should not say that for short period. If I take, I can say time invariant. But in nature also, like human beings, they are time variant systems. But scale of variation is not because human brain only can manipulate things. The systems cannot manipulate things. Of course, if we get an intelligent robot tomorrow, probably it may be able to do that. But as of now, if we take any systems, they cannot manipulate things. They can perfectly follow what guidelines you have given. What you are not giving any guidelines. Basically, you have constructed in that way that it goes and it works in its own way according to natural principles. That is what I say. Okay, and you have the Fourier transform, Laplace transform, Laplace domains, and that is what is another objective. Next one is illustrate different methods of obtaining discrete time signals in systems and analyze them in the Z domain. Okay, discrete time systems means Z domain. Discrete continuous time means Laplace. Okay, so Fourier and Laplace. See here what I have done. Fourier and Laplace domains I have separately lumped together. Okay, that is because for the analog signals, continuous time signals, Z transform separately I will teach to analyze, to evaluate, analyze, understand the digital systems or discrete time systems. Okay, so that is what the objectives. I think I am very clear. I am going to introduce the vectors first and concepts of vectors, vector algebra, few things, and then I am introducing the orthogonal signal space. Okay, then I am approximating the signal in this orthogonal space, and don't be worried about all these new terms. Oh, it is becoming very complex. Don't think they are very easy concepts. Okay, if you continuously attend the classes, if you don't miss classes, it is very okay. Any engineering subject is like that only. Even if you miss 1 or 2 classes, immediately you should make up with your neighbor. Otherwise, you lose it is a story basically. If you take one para, you won't understand. So it is not some kind of social studies, correct? So they are all small concepts only. Then after signal space, orthogonal signal space and signal approximation, I will be introducing the systems, linear time invariant systems, and how they operate on the signals. And afterwards, I am analyzing these systems and signals, both Laplace domain and Fourier domain. And after that, I am using discretization to get the discrete time samples from the continuous time signal, and I analyze that using the Z transform. Okay, so that is what is the sequence. I think if you know the sequence also, it is good for you. Then let us come to the course outcomes. See, course outcomes, it follows some structure, and whatever we have designed is based on this structure. What is the structure? First there is stem. It is called stem. It is the leading statement in the future tense. The students will be able to do. Students will learn. All those things come under this. It is something like we normally call it as a tagline. You can call it as a tagline, or more scientifically, it is a stem. Okay, that is the first sentence. Above all the outcomes, it is written. Then active verb or action verb here. A verb that indicates specifically what the instructor wants the students to know. Okay. So that is what is you have. So here, so a verb that indicating. I think there is some grammar mistake there. Specifically, what the instructor wants the student to know. That is the verb. What is the action I expect from the student? Okay. So this is what I specify as a verb like that, and that verb is applicable on what? Outcome of the action, because I told some action. I expect some action from the student on each outcome. So, what is that action? I have specified here using a verb. Then, what is the outcome of that action? For example, maybe a theory. You can by heart the theorem, or you can derive a theorem. You can derive an equation. You can build a model. You can find a solution by substituting the numerical values. And you may taking a decision that this system is correct, good, or this system is good. Which one is optimized? Which consumes less energy? Which is the less cost product, like that. Okay, process, product, all these things are outcomes. And I am calling it as a focus or object, and I can call, some people call it as a behavior, basically. Okay, so this is what I have. So then contest, there is a additional contest, it is an optional, you can say or you need not say. And sometimes if you say, it is more useful actually, because under what conditions, in what context, because you are not teaching universally applicable things. Okay, and certain context you must have told something, under certain constraints you must have told something. So that's why it is also called as, some people call it as resulting evidence. Okay, this is an optional field, and most probably I always use for this. Okay, this contest I always use, and we have in our institution all of the outcomes are based on this structure, basically. Okay, so we have centralized reviewing process, and we have successfully completed for almost 2 semesters, each and every subject of each and every department. So the course outcomes, let us start with course outcomes. So where is the stem here? Can you identify the stem? So this is the first sentence, is the stem. After successful completion of the course, student will be able to do. This is what is the tagline. This is nothing but stem. Okay, if you see our course file, you will be seeing. Okay, they are all available on our portal. Okay, all the students can download and see, understand that. Okay, so first CO for my course is recall the analogy between the vectors and signals. Okay, so this is what I will be at the end of the course, because I am teaching anyway. At the end of the course, if somebody asks you, what is the relation between vectors and signals? You must be able to say. There is a strong analogy between these two. And you should say there is spaces, signal spaces, function spaces, vector spaces, all those things you must be familiar with. If somebody asks in the examination or in the Viva Versa examination, or if one of your friends, just to test your knowledge, they may ask. So immediately you should be able to recall and tell. So what is the level here? It is the remember level. Correct? It is the first level of the Bloom's taxonomy. Now, here second one is elementary signals and the general classification based on the specific characteristics. Okay, I think first one I will recall the analogy between the vectors and signals and orthogonal function space. What is the purpose here? Resulting evidence. Resulting evidence is what is the evidence? Ultimately, where you are going to use this? This one. Okay, recall is nothing but your verb, action verb. And behavior, analogy between the vectors and the blue color, whatever is there in the blue color, it is called evidence. It is the behavior. It is nothing but object. Okay, it is nothing but focus. The topic focus is this. And contest, what is the contest? What purpose you are doing? Why you are doing this? What is the usefulness of this? Any kind of thing is a contest. For signal approximation using the orthogonal basis functions, my purpose is, by studying this analogy, I will be able to approximate the signals given to me. Okay, I can represent the signals in an efficient way. Approximating the signals is useful for compression of the signals. Okay, that you will study later, not in this course. Afterwards you will study. Okay, then CO2. Summarize the elementary signals. You have the delta signal, delta function, step function, and you have the exponential decay function or exponential raise function. All those things are there. Okay, they are elementary functions, and different power signals, energy signals are there. So you have to classify them based on the specific characteristics. Okay, based on specific characteristics. That is what here you want. If you want to, there is no recalling process here. Recalling means only definition of power, definition of energy. But if you want to classify, you have to understand what is the definition of that. Okay, it is not simple recall. You have to go to understand level. Okay, you should derive sense out of the content which is there in your memory. Then third one, make use of Fourier transform and Fourier series for analyzing signals and systems in the frequency domain. Okay. So here the context is frequency domain analysis. Frequency domain analysis is the context, and make use of, I apply this knowledge. Fourier transform and Fourier series knowledge I am applying. This is what is the object. This is nothing the verb, action verb. This is the action. I am applying action. So it is naturally, it goes to apply. Then what about the explain, again understanding, but this is the, again, earlier I talked about the understanding of the signals. Now it is the understanding of the systems, linear time invariant systems. Okay. So this is what I have again explained, and I am explaining to somebody means I understood the thing. Okay. If I don't understand, I can answer the question, but I cannot explain. The moment I am capable of explaining something to somebody means I understood it, I derived the sense out of the memory content basically. Okay. So that is what is using the convolution and correlation here. Using the concepts of convolution. What is the context here? I mean, what is the tool I used? The concepts of convolution and correlation. See, earlier in CO, what was there? In the first CO, for example, if we take, the purpose was defined. Okay, here first CO if I take, the purpose was for signal approximation. This was the purpose. So for that purpose, you declared this action. Okay, you declared this focus with a certain action. Okay, you expected the student to act like this for this purpose, for signal approximation purpose. Okay, but in this case, in the fourth CO, what you are saying is, you are applying the concepts of convolution. That means you are explaining the linear time invariant system. You are explaining the linear time invariant systems to somebody using something else. Explanation purpose is not given here. How you are explaining? What are the lower level knowledge you used to explain this? That is nothing but concepts of convolution. That means the concepts of convolution here, the concepts of convolution, they are recalled. You know already the concept of convolution and correlation. So you have recalled from the memory the definitions of this convolution and correlation. Then applying them, you are trying to explain them. That means you acquired you recalled here and you are explaining to them. Okay. So there in the first case, you recall the analogy, and why you recall the analogy? What is the purpose of future? You want to classify the signal. That's why you recalled there. Here, I have explained by recalling this. That means, either way you can make the statement. It is left to you how you make intelligently the statements, and how it is left to me as a teacher. But anyway, these framings and all those things, as a student, you are not worried about that one. But why I am explaining this each sentence is, these are the things which are finally to be done by you. Correct? If you have to recall, not the faculty. CO1 means I asked you to recall. I am not recalling. The student, every student in this class should recall at the end of this course, at the end of this semester. Okay. You should be able to recall that. Then you should be able to summarize all signals and compare them. Contrast and compare them, their properties like that. CO2, CO3. Make use. You have to apply something and to do something else. So you have to do that. And you should have the capacity to apply. That means you should recollect, you should understand, and then apply. All those things are involved in this. Okay. CO5. Analyze the continuous time signals and systems. Whenever I say systems, you should remember that. For me, it is linear time invariant system. Simple system. I am not going for very complex systems, but fortunately, these systems are more popular than time variant systems, non-linear systems. Okay. Basically, there will be some kind of non-linearity in every system, but we are ignoring. That's why approximation comes into picture. Signal approximation means even system also you are approximating, and both approximations. Why? If something is a non-linear system, but everything in the world, in fact, with your eyes, how you see, if you have the capacity to see the non-linearity in the system, definitely there will be maybe 1% non-linearity, 99% linearity. Sometimes 50% linearity, 50% non-linearity. Okay. So generally what we talk about is the non-linear portion we ignore, and because most of the times our technology or our discoveries, our purposes are served by the signal approximation of linearity. Linear systems are sufficient to solve many of the problems. But there are some places where you have to you cannot avoid non-linear systems. Correct? So that is required anyway. So that is you can study at PG level, and excellent thing is Volterra filters. If we talk about the filter is nothing but a system, correct? So when you say system non-linear filters means Volterra filters. There it is a one-dimensional signal will undergo two-dimensional convolution. It is a very complex thing and very old concepts. They are very old. Don't think that Volterra filtering is very, let me write here that Volterra filter. And if you want to do something, study. This is an excellent filter you can study. Plenty of problems are there. Of course, highly mathematics oriented. Initially, you may face some problem. So this is the Volterra filter. So this is non-linear filter. Okay. So this is maybe 70 years old or 80 years old. Because mathematicians have used this for their purpose. We don't invent any mathematics. We borrow from mathematics. Okay. Once we borrow from pure mathematics and apply them, we call it as applied mathematics. Mathematicians will call that part of mathematics as the applied mathematics. Correct? So that is what happens. So, plenty of opportunities are there. So here analyzing the linear systems and in the Laplace domain for a system specific characteristics. Similarly, analyze the discrete time signals for a system specific characteristics. Here we are analyzing both signals and systems. Both. See here. Discrete time signals and discrete time systems, both are there. Okay. So whatever is applicable for the signal, same thing is applicable for the system also. Next, we take the CO7 now. That is examine the sampling and reconstruction techniques. This is a separate topic. See, I have told you continuous time signals and discrete time signals. How you get the discrete time signals? By sampling process. You are sampling the continuous signal and you are getting the samples out of the continuous signal. Some part you are ignoring, only the samples you are taking at certain instants. So for that purpose, I use sampling, and afterwards, after sampling, I will process the signal, digitize the signal, basically process the signal, and because after sampling, there is no other option. After sampling, what you do? You directly go digitize and apply the digital signal processing. Again, get back the signal to the analog domain. That means continuous time domain. So that is done by the reconstruction process. Digital to analog conversion, DAC, it is called. Sampling is done by A to D converter, analog to digital converter, ADC, analog to digital converter, and digital to analog converter. So these are the techniques for converting between continuous time and discrete time, band limited signals. Okay, this band limited we study later. So this is what examining. You are examining. That means you are analyzing these things. Techniques you are analyzing. So which one is better? And what is the disadvantage of each method? So like that you will be separately doing that. And CO8 is, we are computing the energy or power density function. Fourier transform gives magnitude spectrum, voltage spectrum, and now we talk about the power spectrum or energy spectrum. Okay, power signals, energy signals, we are not going to discuss now anyway. So there are power signals, energy signals. You can estimate the energy density function or power density function for these two kinds of signals and systems also. Okay. And if it is a signal, you call it as if it is a signal, what you call? I have given a signal. I found the power spectrum for that. What you call? Power spectrum of the signal, I should say. I have found the, voltage. So I have given a voltage. I am finding the Fourier transform of that one. I should say that magnitude spectrum of the signal or phase spectrum of the signal. That I call in case of signals. If I take systems, I should say that frequency response of the system. Okay. Not the frequency spectrum. Frequency spectrum you have to use only in reference to the signals. Okay. What is the frequency spectrum? What is the frequency spectrum of a triangular wave. What is the frequency spectrum of a rectangular wave? Like that I should say. If I use a filter, low pass filter, high pass filter, then I should say that it is a system basically. I should say that frequency response of the system, I should say. I should not say that frequency spectrum of the system. Okay, you should be very careful in that sense. So why I spend some time here is, you will understand the content in a better way in future. Okay, so this is energy spectrum. Then CO9. Apply the correlation function in the signal detection and extraction. This is the last one, CO, and has direct practical application here. You are detecting the signal. Something signal in buried in the noise. Radar signal. Very low voltage is appearing. Okay, very microvolts, or your brain signals are very low, microvolts level. Then put some electrode here. There are 128 electrodes, or 256, 512, 1024 electrodes also you can put here. Some sensors here you can put. You can note down the brain. Throughout your skull, what is happening. All voltages you can record. They are all microvolts. Okay. So, basically if they are noisy, then you should detect the original signal out of that IC. And you have to extract the signal from the noise, or you should detect the signal, as in case of radar or in case of something else. Okay. So, you have to do, these are different applications. So these are the COs, and if I see the distribution of the COs as per the Bloom's level, first level I have only one CO, okay, remember level, 2 COs are there in the understand level, and 3 COs are apply level, 3 COs are analyze level. That means up to 4 levels I have gone in this, though it is an introductory subject. Is the signal and system analysis. Signal, the name itself, the course name itself, signal analysis and system analysis. Signals and systems means analysis of both. I am not synthesizing. Here I am only analyzing. Okay. That's why I have gone up to the analysis level, and it depends on the faculty, how the faculty delivers the content. And to my knowledge, to my capacity, this is how I have done. And different faculty members probably will show you different graphs here, but it doesn't matter. Somewhere it will be captured. Okay, in one of these COs, all the content is captured, and all these 9 actions you are supposed to do. The student, as a student, you are supposed to understand from CO1 to CO9. You should be able to understand to complete this course, to gain more insight or more benefit, to take more benefit out of this course. All students have to, in fact, even if you by heart also, it is not harmful. Okay, you should know CO7, CO6, because every unit probably 1 or 2 may be having, okay, COs, or some COs may be spanning across the units, maybe 3-4 units together, small part. So across the units also, some COs may be there. Okay, so you should be in this way. If you know this CO order, another benefit for you as a student is, you will be able to create a structure basically. Okay, when I am teaching signals and systems course, you have to store every day. I am giving some knowledge to you. You have to store that knowledge as a tree. That means you should have the bird view. Why I have given all these things? Why I have spent my first hour totally on this is, you should have. I have put some seed now in your brain. Okay, it has some stick I have put. You have to grow the stick into different branches. So you have to, whatever I am giving knowledge, your knowledge is stored as a tree basically inside the brain. Otherwise, you cannot recall it. That's why if you want to say something to somebody, always say it as a story. So one step afterwards, next step, they are all linked, like linked list, double linked list. I should say double linked list. So after one link, another automatically. That is how the human brain process works, recall process. So if you store the knowledge as a tree, that means it should not be fragments. Say in this corner of the brain, some part, and first unit somewhere, second unit somewhere, third unit somewhere, signal somewhere, and system somewhere, Fourier series somewhere, and you should not do like that. You should know the link among all these domains: Fourier domain, Laplace domain, and first thing time domain, transform domain, time domain, and transform domain. Under transforms, I have the Fourier transform, Laplace transform, jet transform. That is what I am doing, and I have signals and systems, 2 classifications. So overall content, you should know the structure of that, how it is organized, how it is. You should have the bird view of that one. in that case, then every day when I give some knowledge to you, you will put that one in that box, knowledge. Okay, the structure is well identified. Of course, now you won't be able to do that. At the end of the course, you should build an excellent tree out of this knowledge. Okay, then you will never forget it. And one tree of signals and systems, you won't be confused with the signals. I mean, tree of the microprocessors. Okay, microprocessor, signal processing, image processing, antennas, they are all different trees, different courses you are studying. Each has its own tree. Okay, there is no confusion basically. If you store as a tree in your brain, there will not be any confusion. Okay, so that is the purpose of the giving this kind of overview for you. And syllabus is like this. I think everything. First one is vectors and signals, as I told you. Second one is Fourier analysis, Fourier series and Fourier transforms, 2 parts. Then third one is signal transmission through linear systems. This is where linear time invariant systems comes into picture. And fourth module is Laplace transform and jet transform, both combinedly. Okay, Laplace transform is for analog signals, continuous time signals. Jet transform is for discrete time signals. So 2 parts again here. Then module 5 again 2 parts here. Sampling theorem and correlation. Okay, and in fact, this different departments, different faculty, they organize this knowledge in a different ways. Okay, and this doesn't matter, but the sequence is more important. The sequence you should follow as specified in the textbook, because if you take the textbooks, first textbook if you take Signal Systems and Communications with Pilati, it is 2009, but original print was in 1968. So they are all Star Wars, except they are the people who created this. I mean, they have not created the signals and systems, but they have created how to organize this knowledge in the form of a textbook. Okay, they are the pioneers in that one. So natural sequence is there for each textbook, and you can form your own sequence of storage in your brain. Okay, and I have given 3 references also, and whenever you have time, you can go through the references. Don't see this course simply to get a tool for getting the marks. Don't see that. Okay, it doesn't matter whether you get 90% or 70%, and whether the concepts are printed in your brain accurately, and are you able to retrieve that whenever you require. Concepts I am saying, I am not saying by hearting. And at the end of the course, in fact, at the end of the course, after the examinations are over, you should remember, let us say 90% of it. After 1 week, some part. After 1 month, after 1 year, you should remember at least 5% of the course. Nothing more than that. 95% you don't remember word by word, but 90 concepts, 5% only. It is the juice out of the fruit. So that juice, if you know, and the juice, whenever you require, you take that small word, keyword, and go to textbook and expand one, which is already stored in your brain. Okay, so that's why you should be very careful, and I say that is very, very important course. I hope you enjoyed my lecture, and thank you for your patience, and let us have a good time. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.